Hello. Today we are doing our Intro to Polynomials lesson. That's going to kick off the rest of this unit. We're going to talk about parts of polynomials and what makes something a polynomial. The first thing we're going to do is the warm-up. So the warm-up is about Alyssa creating a blanket using two types of fabric. You should have already done this warm-up. I'm just going to go over it. The dimensions of the blanket and the two different fabrics are shown in the diagram that follows. Alyssa is still deciding on some of the dimensions, and the variable x represents the undecided lengths. So we need to do a little bit of annotation here so we know what we're dealing with. So we need to know what x represents, the undecided lengths. She still needs to know what dimensions. Dimensions are your length and your width. If you don't know what the word dimensions means, length and width. So we need the perimeter, which is the distance around the outside of the completed blanket. Find that perimeter. So I would use the expressions on the outside. So I have 72, and it's in inches. We'll put our answer in inches, plus 42. But I have two more sides. So I have another side that is 72 inches and another side that is 42. So I want, I could do 2 times each of these, or I could just add 72 and 42 again. So you can take your calculator, add 72 plus 42 plus 72 plus 42, and you should get 228 inches. And this is inches, not inches squared, because we are just adding the inches together. We're not multiplying inches times inches. That would be area. What about the expression for the perimeter of the rectangle? So the rectangle in the center, the inner rectangle, has a length of 42. Take away these two x's. So how would I write an expression for that? Well, the shorter side is going to be 42 minus x, or 42 minus 2x. And what about the longer side, the length? That was the width. The length would be 72 minus what? What am I taking away? I'm taking away a 2x here and a 2x here, so 72 minus 4x. So the perimeter of the inner rectangle is going to be 2 times the longer side plus 2 times the shorter side. What do I do with this mess? Well, remember your order of operations. You multiply, distribute here, so 2 times 72 is 144. 2 times negative 4x is negative 8x. Plus 2 times 42 is 84. Remember the arrows that some teachers use. Plus 2 times negative 2x, or negative 4x. And what like terms do you have here? Well, you've got 144 and 84, and then you've got your negative 8x and your negative 4x. So when you add these together, 144 plus 84, and you get 144 plus 84. You get 228, and negative 8x minus 4x is negative 12x. So the perimeter of the inner rectangle, we don't know, but we know it's 228 minus 12x inches. She doesn't know what she wants to use for the x. So that's the warm-up for today. Today's lesson is going to be talking about expressions. They can be used to represent quantities when the quantities are a sum of other values. When there are unknown values in the sum, we use variables. So variables are unknown quantities, right? You've been learning that since middle school or before. Expressions with variables raised to powers are often written in a standard way. This allows expressions to be more easily compared. Powers would be like 2x squared. Now you've got a power. So there's a certain way we write those expressions when they have terms that have powers in them. So let's go way back to the very beginning. What is a factor? Well, a factor is one of two or more, and now you're going to start filling in your notes, two or more numbers or expressions that when we multiply them together, you get a, what's it called when you multiply two things together? You get a product. Okay, so you could have the expression 2a. That would be 2 times a, so your factors are 2 and a. If you just have a number, like 6, two of the factors of 6 would be 2 times 3. You could have, like what I wrote on the previous page, 2x squared. That's 2 times x times x. So you've got 3 factors in this expression. Exponential expression. That's an expression that contains a base raised to a power, which sometimes we call that an exponent. For example, we have a squared. That's an exponential expression. What is the base of that? Well, the base is always the number on the bottom, the big number. So that would be a. And what is the power? The power is your exponent, so that's 2. You could write an exponential expression like in the basic functions activity, 2 to the x. The base is 2, and the power is x. So you could have an exponential expression with the variable that is a power. So now we're up to polynomials. What is a polynomial? That's an expression that contains numbers and or variables where the variables are raised to powers greater than or equal to 1. Okay, we can't have negative exponents. You're not going to have 0. Well, you could, if you have a 0 exponent, you just have the constant 1. Okay, so for example, 2x squared plus 1 is a polynomial. You've got 2 terms, okay, and they're added together. They may or may not, you may or may not have more than one term. So what is a term? That's a number, a variable, or the product of numbers and variables. And the terms in this polynomial here are, and how many terms are in there. So you should be thinking ahead and trying to predict what I'm going to say. Normally I would stop here and have my students say what the terms are. So you can think about that. What are the terms? Well, the first term is b to the 6th power, but comma. The second term is positive 2a, so we're just going to write 2a. And the third term is negative 4, because that's minus 4, so we're going to say minus 4, negative 4. So those are your 3 terms. The degree of a one-variable polynomial, so in other words, a polynomial with such as 3x squared minus 4x plus 2, there's only one variable in here, whereas there were 2 variables in here. We look at the greatest power in here. So what's the greatest power in this polynomial? Well, this one doesn't have a power. This one has a power of 1, and this term has a power of 2. So the greatest power in this one is 2, so this would have a degree of 2. So it's the greatest power of the variable. So we have a standard polynomial written in standard form, has a bunch of numbers and letters that look confusing. Really, these are just the constant terms or coefficients. These are the powers of the variable. And then this would be your constant term, the term with no variable. So A1 is always going to be a rational number. So you couldn't use like pi, because that's not a rational number. for a coefficient. And then any of your these a's, the coefficients, these cannot be 0, because then you wouldn't have the polynomial. And n is always positive. And n is always the degree, because n is your highest power. Okay, so in the example on your sheet, I want to oh, you don't have it, so I'm going to show it to you. So you've got this example. You need to copy that on your sheet. So ask your teacher to pause the video. So you have the polynomial 8x to the 5th plus 7x cubed plus x squared plus x. What is the degree of this polynomial? Well, let's see, our powers, this would be 1. This has a power of 1. So 1, 2, 3, 5. The powers, again, are these numbers. Don't look at the coefficients, look at the powers. The power is 5. The highest power is 5, so the degree of this polynomial is 5. Okay, and in that same polynomial we have coefficients. The coefficient is the number in front of the variable. So in that same polynomial, you've got coefficients. Now we're looking at these numbers. Remember, if there's not a number there, the coefficient is 1. So we've got coefficients of 8, 7, and 1. There's 2 coefficients of 1. If there is no coefficient, so the coefficient is 1. So like up here. Like up here. The leading coefficient, you'll hear us talking about that, us math teachers talking about that a lot. What is the leading coefficient? It's the coefficient of the term with the highest power. Okay, so you've got the example 4x to the 5th plus 9x to the 4th plus 3x plus 12. The term with the highest power, again, remember our power, this one would have a power of 0, 1, 4, and 5, is this term. So you know the degree, according to what we did up here, is 5. But that's not the lead coefficient. The term with the term with the highest power is 4x to the 5th. So the lead coefficient is that 4, the number in front of the variable. So it's really easy to confuse the highest power, the degree, with the lead coefficient. The lead coefficient is that coefficient of the term. The power is that little number on the top right. Descending order. So when we write polynomials, we always write them in descending order. So terms in a polynomial are ordered by power of the terms with the highest power first. So you list them from highest to lowest power. So the constant term is that last term usually. It's always going to be the last term because it doesn't have a variable, right? That's why we call it the constant term. It won't ever change, so it's constant. And that is always listed at the end because that power of the constant term is 0. Why is that 0? Well, let's see. If I have anything to the 0 power, it equals 1. So 2 times x to the 0 would be 1 times 2, which is 2. That gives me the constant term, that last term. So for instance, the 12 here, you could write that as 12x to the 0 because 12x to the 0 is the same as 12 times 1, which is 12, since x to the 0 power equals 1. Okay, so we've got some examples for you to work through. It's easy to order terms incorrectly order the terms because a lot of people look at the coefficients instead of the powers. Make sure you're looking at the powers. And then you can only combine like terms if those variables have the same power. So you can't add 2x to the third plus 2x squared, because although they have the same variable, the variables have a different power. If I had 2x to the third plus 2x to the third, then you can add that and make it 4x to the third. The powers don't change, just the coefficients change when you add. So identify the terms in this expression. So the terms. And I want you to try these 3 examples before I do them on the board. So at this point, the video should be paused. And as a class or with your partner, go ahead and try these 3 problems. And then turn it back on after you finish. Okay, so the terms in this expression, first of all, there's 3 terms. They're going to be 5a squared, negative a, and 7. What is the highest power, or the degree? Well, the degrees are 2, 1, and 0, so the highest power is 2. For example 2, we've got the expression negative 2x to the 8th plus 3x squared minus x plus 11. Coefficient, variable, and power of each term. So I'm going to put the coefficient, variable, and power. I'm just going to make a column. So the terms are negative 2x to the 8th, 3x squared, negative x, and 11. The coefficient of this one is the coefficient, variable, and power. Coefficient is negative 2, the variable is x, and the power is 8. For the second term, the coefficient is 3, the variable is x, and the power is 2. For the third one, there's nothing there, but remember you can put that 1 there, so it would be negative 1, x, power is 1. The coefficient is 11, and you may or may not have put x to the 0. That would be fine if you didn't put anything here, but if you did, you would say it's x to the 0 power. And example 3. Write a polynomial function in descending order that contains the terms negative x. So let's start out. Let's just write it out. Negative x plus 10, x to the 5th, plus 4x to the 3rd, plus x squared. But I want it in descending order. This is not, because the highest power in this one, remember this is the power of 1, is 5. So I'm going to write 10x to the 5th. My next highest power is 4x cubed, so I'll write 4x to the 3rd. And then we go with x squared, because the next highest power is the 2, and then we'll put the minus x at the end. What is the degree of this function? Well, that's the highest power, which is 10. And let's take it one step further. The lead coefficient is this 10. Uh-oh. See, I made that mistake. You guys hopefully caught me. The degree is 5, and the lead coefficient is 10. Okay, that's the end of